Hi students, Mrs. Keller here with a video for you about transforming the sine and cosine functions. So let's start off with looking at the notes here. You'll notice that we have the sine and cosine equations, and you'll notice some new letters. So you'll see the A and the B that we've been dealing with in the previous couple of weeks. And so A, if we recall, the absolute value of A is the amplitude, and if A is negative, it causes that vertical reflection, and B is that number of cycles within 2 pi. But now let's take a look at H and K, and these have just been added this week into our lesson. But don't be worried. H and K are our friends from long ago. They do the same thing that H and K have been doing to all of our functions that we've been learning since the beginning of the year. So you'll notice that H is here inside the function, and it causes a horizontal translation. It shifts the graph left and right. And for the sine and cosine graph, we call that a phase shift, that shift left or right or horizontal. So for example, if in this top equation we have theta minus 1, that's going to shift the graph to the right 1 unit because it always goes the opposite direction of what you would think. Remember, shake your head horizontally. It doesn't go the way you would think. If this said theta plus 1, it's going to shift the graph left 1 unit. K is the same K that we've been dealing with. K shifts the graph vertically, up or down. And if you shake your head vertically, you'll recall that it does go the direction you think. So on the outside of this equation, if this said plus 2, that would shift the entire graph up 2 units. And if it said minus 2, it would shift the graph down 2 units. So K hangs out on the outside of the equation, shifts vertically. H hangs out inside the function next to our variable theta here, and it shifts the graph horizontally, goes the opposite direction that you would think. So let's take a look at an equation and see if we can find all the transformations. So here is a sine function with lots of different transformations happening. So let's take a look and see. The amplitude, if we recall, is the absolute value of A. A is always that number that's multiplied in front of the function. So in this case, the amplitude is 4. The period, we find the period by taking 2 pi divided by the number of cycles that happen in 2 pi. The number of cycles comes from this value B. So 2 pi divided by 3 is our period. The phase shift, remember that's the horizontal shift, left or right, is going to come from H. So you'll see here we have theta minus pi over 2. So it goes the opposite direction you would think. So we're going to shift our graph actually right pi over 2 units. And lastly, our vertical shift comes from this number on the outside of the function, plus 1, meaning our graph will shift up 1 unit. Now let's see if we can take a list of transformations and write a function. So the instructions here say to write a cosine function. So notice we'll be using our cosine equation up here. And let's see if we can find A, B, H, and K, and then all we have to do is plug them in. So if I read across here, it says a cosine function with an amplitude of 3. Amplitude is always going to tell us that A value. So A is going to equal 3. It has a period length of pi units. So this time we know the period, but we want to find the value for B. So to find B, you simply take 2 pi divided by the period. 2 pi divided by pi is 2. So our B value would be 2 for this function. It is shifted to the left pi over 3. And so keep in mind here, we're always going to be doing the opposite thing. So actually to the left pi over 3 is going to be negative pi over 3. That's going to change once we write our equation. You'll see in just a moment. And lastly, we have a shift up 1 unit. So our K is going to be a positive 1. When we go to plug all those values into our equation, this is what we end up with. The A fits right here. The B fits right here. Notice we said that H was negative pi over 3. Our equation is always theta minus H. So if we said theta minus a negative pi over 3, we get our plus pi over 3 right here. And then we have that plus 1 K hanging out on the outside of the function. So you now know how to find the amplitude, period length, phase shift, and vertical shift from an equation. And you also know how to write an equation if I give you those transformations. So good luck.